Picture this. You're sitting in your Cambridge IGCSE computer science exam. The clock is literally ticking down, the pressure is totally on, and you flip to this massive high-mark question about storage devices. You read the prompt, take a deep breath, and jot down what you think is a perfectly logical, super safe response.
You're right. A USB drive is used to save files so you can use them later on another computer. I mean, it sounds completely reasonable, right? It's exactly how we talk about storage devices in our everyday lives. You put your pen down, totally confident you've just bagged those marks.
0. Not a single mark awarded. No way, right? That answer, even though it's technically true in a day-to-day sense, scores absolutely nothing on the Cambridge mark scheme. Why? Because it completely lacks the precise technical mechanics and the specific scenario application that examiners are actually hunting for. It's just way too generic for a highly specific question.
Okay, let's dive into this. If we really want to rescue these failing answers and turn them into top-band responses, we've got to stop thinking like casual tech users and start thinking like actual computer scientists. And that means wrapping our heads around the hidden, microscopic mechanics of how these storage devices actually hold your data.
Section 1. How flash memory actually works. Zooming to atoms.
The syllabus explicitly requires you to understand solid-state storage, which, is also commonly called flash memory. This is the exact tech inside your USB drives and SSDs. To really get it, we have to zoom way down to the atomic level. So all atoms are made up of electrons, right? These tiny particles constantly buzzing around. Now, an electric current is just a flow of these electrons. But here is the absolute critical part. An insulator is a material that acts as a roadblock. It doesn't normally let those electrons flow through it. It literally stops the current dead in its tracks.
So here's how that physical reality actually builds into a memory device. Step 1. A massive flash of electricity is applied. It's so strong it forces those electrons straight through that insulator barrier. Step 2. The electricity is abruptly removed. Step 3. Because that insulator barrier is right back in place, those electrons are now totally trapped on the other side. They are physically stuck. The memory device can then detect exactly where these stuck electrons are, and it reads those specific locations as our binary data, ones and zeros. There are absolutely no moving parts here, just trapped particles. It's like a giant microscopic puzzle. Now that we've got the technical mechanism down, you might be wondering, okay, how do I translate this into actual exam marks? Well, in a moment, I'll show you the examiner clue that changes your answer completely. But first, you need the comparative framework that makes that clue super obvious.
Section 2. Solid-state versus optical media. Choosing the right media.
The exam will constantly ask you to choose the right storage for a specific job. To pull that off, look at the sheer physical difference between these technologies. On one hand, solid-state drives, or SSDs. Like we just learned, they rely on trapped electrons. This means zero moving parts, no spinning disks, no moving arms, nothing. On the other hand, optical media, think CDs, DVDs, and Blu-rays. These rely on a completely different mechanical reality. They use literal physical lasers to read pits and lands on a physically spinning disk. That mechanical movement means they're just inherently slower to read and write data. And honestly, they're way more susceptible to physical wear and tear, or getting damaged from being bumped or scratched.
Section 3. Real-life storage scenarios. Applying knowledge.
And this brilliantly illustrates where the Cambridge exam really tests you. They demand that you apply this knowledge to real-world situations. Take a classic example, straight from the syllabus, a building management system, or BMS. A BMS is basically a computerized system that constantly monitors and controls a building's environment. We're talking nonstop, continuous inputs from sensors tracking the temperature, controlling lighting, managing electrical power, and instantly reacting to fire and access systems. This requires massive, and I mean massive amounts of continuous data to be stored and processed instantly.
Of course, the exams might throw other scenarios your way too, like teleworking or cloud services. In those cases, you'd need to discuss how data isn't just sitting locally, but it's sent securely over an internet connection to some remote cloud storage. You'd weave in concepts like passwords, data encryption for safe e-commerce, and the sensible user behavior you need to keep that remote data safe. But let's stick with our building management system for our next challenge.
Section 4. The examiner's challenge. Evaluate the answer.
All right, it's time for you to step into the shoes of the Cambridge examiner. Here's a student's submission. The BMS uses a DVD to store continuous temperature data because it is cheap. I want you to spot the critical error in this combination of storage medium and real-world scenario.
Just pause for a second and predict exactly why this is completely wrong. Think about write speeds. Think about moving parts. Think about the physical reality of continuous sensor data. A BMS is yanking in temperature data every single second, 24/7. A DVD, that's optical media. It has to physically spin up, and a laser has to physically move across the disk just to write. The latency is way too high, the write speeds are vastly too slow, and that constant mechanical writing would cause the drive to fail incredibly fast. It is literally the absolute worst tool for the job.
Section 5. Crafting the perfect answer. Guaranteeing full marks.
So, we know exactly why the generic answer and the DVD answer failed. Let's fix this with an upgraded answer formula that guarantees full marks on paper 1. You can't just state a generic idea. You have to tick off very distinct technical points. First, identify the core concept. Second, state the underlying mechanism. Third, tie it directly to the scenario example provided in the prompt. And fourth, use precise examiner wording to describe the advantage.
Let's apply that formula right now. The BMS uses solid-state storage for temperature data because its lack of moving parts ensures fast, reliable read/write speeds for continuous environmental monitoring. So the crucial point is that we didn't just say it's fast. We explained why it's fast, the lack of moving parts. And we didn't just say it stores data, we said exactly what kind of data, directly linking it back to the scenario.
And that brings us to the secret weapon, closing that loop we opened earlier. The examiner clue revealed. Scenario nouns. When a question gives you a specific context, like a building management system, or temperature sensors, or a teleworker, the mark scheme absolutely demands that you use the exact nouns from the prompt in your answer. If you just write, "It stores data fast," you lose marks. If you write, "It stores temperature data fast" for the BMS, you unlock the marks. You're proving to the examiner that you're applying your technical knowledge to their specific problem, not just reciting a textbook.
So, here is the big question for you. You now know the precise mechanics of trapped electrons in storage, you know why optical media fails for continuous tasks, and you know the secret of scenario nouns. But can you consistently structure these perfect multi-part answers while the exam clock is relentlessly ticking down? Because honestly, technical knowledge is practically useless if your execution speed fails you on exam day.
Knowing the facts is really only half the battle. Formatting them efficiently is the key to an A-star. The full rescue kit continues in our timed answer writing system explainer. Watching that explainer is your mandatory next step to ensure you never lose marks to the clock again. It's going to train you to deploy this exact framework at high speed.
Subscribe to our YouTube channel Ace the Exams @AceTheExams_IGCSE to excel in your Cambridge examinations.